If you have ever watched a Codex project look brilliant in the first hour and strangely confused on day 3, the problem was probably not your prompt. That is the comforting myth. We tell ourselves that if the system drifts, we just need cleaner wording, better structure, or one more clever instruction block. But long-term work does not usually break in a dramatic way. It breaks quietly. Tasks get repeated. Old decisions fade. The agent looks busy, but the project starts losing its shape. So this video is about the real fix. Not prompt engineering as a coping strategy, but orchestration. Specifically, how Codex Subagents, persistent project memory, and evaluator gates can keep long project cycles coherent. A flat prompt works surprisingly well when the job is short. One model, one instruction, one burst of tool use, one output. But a long-running project is not one burst. It is a chain of decisions, artifacts, handoffs, errors, reversals, and partial wins. Once that chain gets long enough, the prompt stops behaving like guidance and starts behaving like a weak operating system. It has no durable memory model, no formal resume point, no clean separation between planning and execution, and no serious external judge. So the project accumulates fog, not because the model is useless, but because the control layer is too thin for the timeline it is trying to manage. You can feel this failure in a real repo. On Monday, the system scans the codebase and writes a decent migration summary. On Wednesday, it scans half the same surface again, because the earlier conclusion was never turned into durable project state. On Friday, a risky branch is still floating around because nobody preserved a clean handoff about why it was paused. That is what long-term drift actually feels like. Not a spectacular crash, just repeated discovery and weaker control. This is where Codex becomes more interesting, because OpenAI frames the Codex app as a project command center. Separate threads organized by projects, parallel agents, and isolated work trees, so one branch of work does not poison another. But that does not mean you should explode every task into 10 agents just because you can. OpenAI's own practical guide is careful here. Start with a single agent first. Add more only when complexity really demands it. So the useful question is not, should I use subagents? The useful question is, what kind of separation actually removes pressure from the system? In a strong Codex workflow, the lead agent owns planning, coordination, and the first judgment about what matters next. Smaller subagents take bounded slices of work. Search the codebase. Review one large file. Process supporting documents. Build one narrow artifact. And an evaluator gate checks whether any of those outputs deserve to become part of the main project memory. The hierarchy earns its keep only when it buys clarity and judgment. Now we get to the phrase that sounds more magical than it really is: persistent autonomous memory. If you frame it badly, it sounds like the model has developed some permanent mind of its own. That is not what matters here. The real issue is project memory. What decisions were made yesterday? Which risks are still open? What spec version is current? Which branch already tested that idea? What handoff summary should the next run inherit? Official OpenAI language talks about working context that carries memory and history, tool state, workflow state, and identity boundaries across steps. That is the grounded version. Persistent memory is not leftover chat. It is a designed layer that helps the project remember what matters without drowning the next run in stale noise. This is what makes multi-day work possible. Without a memory layer, the system keeps rediscovering the same facts and reopening the same questions. Without checkpoints, it cannot resume cleanly. Without scoped handoffs, one run dumps a giant messy scroll onto the next. So a durable Codex workflow needs a rhythm. Checkpoint the plan. Save the current artifact. Record what changed. Record what failed. Record what still needs judgment. Then let the next cycle start from that structured state, instead of from a half-remembered prompt and a bloated window full of decaying context. That is the difference between a demo that looks autonomous and a project that can actually survive the week. In practice, this creates a very different Codex workflow. In the weak version, one agent scans the repo, writes a plausible summary, maybe drafts a patch, and leaves behind a long scroll of text that the next run has to reinterpret from scratch. In the stronger version, the lead Codex agent expands the goal, sets the branch of work, and decides which bounded jobs deserve delegation. One subagent scans a subsystem, another drafts a migration plan, another reviews a risky file or supporting document. Their outputs return as artifacts, summaries, diffs, notes, recommendations. Then an evaluator gate asks the harder question, should any of this survive into the main line of the project? Only after that judgment does the project memory update. So the memory is not passive storage. It is a filtered record of what the system has decided to carry forward. This is also why prompt engineering eventually hits a ceiling. You can absolutely improve a run with better instructions. OpenAI says so, and that remains true. But prompts cannot do the whole job once the workflow spans real time. They do not replace resume logic. They do not replace state boundaries. They do not replace scoped delegation. And they definitely do not replace an evaluator that can stop low-quality work from quietly becoming the new baseline. The deeper truth is that long-term Codex reliability is less about persuasive wording and more about disciplined system design. So if you want Codex to survive long-term project cycles, think less like a prompt crafter and more like a systems architect. Use subagents where they isolate real complexity. Treat memory as project infrastructure. Preserve resumable state. Make handoffs clean. Add evaluator gates that can say no. That is how a long-running workflow stays coherent, without pretending one brilliant prompt can carry the whole thing forever. Past a certain horizon, the best AI workflow is not the one that sounds smartest at the start. It is the one that still knows what it is doing after days of work.